Okay, so now I'm going to look at an integral that involves a trig substitution in which you first have to complete the square. So in the denominator of this, I see a radical, but there's no sum or difference of squares there. But what I can do is, I can go ahead and I can complete the square underneath that radical to create a sum or difference of squares. So this is what I'm going to do. I'm going to have the x squared plus 4x. I'm going to add in the magic number that I need to make this into a perfect square trinomial. And then I still have the plus 8. But the number I need, I'm going to add it in and subtract it off. So whatever number I need to make it into a perfect square trinomial, I'm going to add it in and subtract it off. It turns out that the number I need is half of that squared. Half of 4 is 2, and 2 squared is 4. So I need to add in a 4 and subtract the 4 off. That way, these first three terms are just x plus 2 squared when you factor them. So those first two terms factor into x plus 2 squared. And those last two terms combined to give you 8 minus 4 is 4. So here is what I've done. I've changed this integral into this integral by completing the square under the radical. So I get this now, and I see I have a sum of 2 squares. Well, we're going to create our representative triangle here for the trig substitution. This is going to be theta. This is going to be the right angle. And since it's a sum, I know that these two are the legs. I know these two have to be the legs. So I'm going to let this be x plus 2, and I'm going to let this one down here be 2. Because now this hypotenuse, using the Pythagorean theorem, is just going to be that. X plus 2 squared plus 4. If you use the Pythagorean theorem, this squared plus that squared is equal to this squared. Take the square root. So that is a representative triangle. And if you take a look, this is how I want to make my substitution. Opposite adjacent is the tangent. Tangent of theta. The tangent of theta is equal to the opposite side, x plus 2, over the adjacent side, 2. So here's where I get my u substitution from. I multiply both sides by 2, so I get 2 tangents of theta is equal to x plus 2, and then x is equal to 2 tangent theta minus 2. So that's my u substitution. X is equal to 2 times the tangent of theta minus 2. So since I know x, I'm going to find dx by taking the derivative of x with respect to theta. Dx d theta, well, the derivative of the tangent is the secant squared, and the derivative of negative 2 is 0, so I get that dx is equal to 2 secant squared of theta d theta. And there I have everything I need for my substitution. So I'm going to go ahead and substitute. Integral. Well, x we said was 2 times the tangent of theta minus 2. That's x. Divided by, and then, well, let's see. Square root of x plus 2. Well, x plus 2 is actually 2 tangent theta. Based on this, 2 tangent theta is equal to x plus 2. So here I have the square root of 2 tangent theta squared. And then plus 4. Plus 4. But I also have to substitute in for dx. And dx is 2 secant squared theta d theta. 2 secant squared theta d theta. So this is the new integral. And let's see what I have here. This is the integral of, this is going to be 2 times the tangent of theta minus 2 times 2 secant squared theta d theta over, and in the denominator I see this is going to be the square root of 2 squared is 4, tangent squared of theta, and plus 4. So I can factor a 4 out of the two terms underneath the radical, leaving me with this. This is going to be 2 tangent theta minus 2 times 2 secant squared theta d theta divided by, and I factor out the 4, and I take the square root of 4. If I factor the 4 out and take the square root, I get 2 square roots of tangent squared of theta plus 1. So, coming back over here, let's see. Coming back over here, well, I can also factor 2 out of this factor here. So this is the integral of 2 times the tangent of theta minus 1 times 2 secant squared of theta over 2 square roots of tangent squared theta plus 1 d theta, and these 2's cancel out. And actually, by the Pythagorean identity, the tangent squared of theta plus 1 is actually the secant squared of theta. So I get the integral of the tangent of theta minus 1 times 2 secant squared of theta over the square root of, and then the secant squared of theta plus 1 is the, or the tangent squared of theta plus 1 is the secant squared of theta, d theta. So I have all of this. And let me see. Well, the square root of the secant squared is just a secant. So I get the tangent of theta minus 1 times 2 secant squared of theta over the secant of theta d theta. All right, let me just transpose this triangle, because I'm going to need that triangle at the end to do my back substitution. So this triangle here is what I'm going to need. It says theta here, x plus 2 here, 2 here, and this one is the square root of x minus 2, or x plus 2, sorry, squared plus 4. So, here we go. Now, one of these factors of secant cancels out, leaving us the integral of the tangent of theta minus 1 times 2 secant theta d theta, which is relatively simple. Let's see, we have the integral. I can distribute that, so I get 2 times the secant tangent, the secant theta tangent theta, and then minus 2 times the integral of secant theta times theta. Oh, I forgot the d theta here. D theta. And d theta. And then minus 2 times the integral of the secant of theta d theta. So now I have 2 integrals that I can actually do. Let me see. This integral here, the integral of the secant tangent. Well, when I take the derivative of the secant, I get secant tangent. So if I integrate secant tangent, I should get secant of theta. Now minus 2 times, when I integrate the secant of theta d theta, well, the integral of the secant is the natural log of the secant of theta plus the tangent of theta plus c. So this is going to be times, this integral is the natural log of the absolute value of the secant of theta plus the tangent of theta, and then this is going to be plus c. Alright, so I get this after I integrate. I get that after I integrate, but now I have to figure out something to do with these integrals, because this answer is in terms of theta when the original problem was in terms of x. So now I'm going to do my back substitution. The secant of theta. Well, the secant of theta, secant is the reciprocal of the cosine function. Secant is the reciprocal of the cosine. So if cosine is adjacent over hypotenuse, then secant is hypotenuse over adjacent. And minus 2 times the natural log of the absolute value. Well, once again, we just said the secant was the square root of x plus 2 squared plus 4 over 2 plus the tangent. Well, the tangent is opposite over hypotenuse. So that's x plus 2 over 2, close that, plus plus c. So here we have the expression that gives us the antiderivative. So we've integrated using the trig substitution, where we first had to perform completing the square.